So this is chapter 5 from Physical Geography, class 11, NCRT. So previously I have done chapter number 4, and this is chapter number 5. Let's go through it. So chapter number 5, it's called geomorphic processes. After learning about the Earth, how Earth was born, how it evolved with crust, other inner layers, and how its crystal plates moved and are moving, and other information on earthquake, the form of volcanism, and about the rocks and the mineral the crust is composed of. It is time to know in detail about the surface of the Earth on which we live. Let us start by discussion. What is the surface of Earth? Why is the surface of Earth uneven? The Earth's answer is the Earth's crust is dynamic. Like it's not same all the way. You are well aware that it has moved and moved vertically and horizontally. Okay. Of course, it moved a bit faster in the past than the rate at which it is moving now. The differences in the internal forces operating from within the Earth, which build up the crust, has been responsible for the variation in the outer surface of the crust. So, what is responsible for the outer layer? It's the internal force, which is called endogenic, like which comes from the inside, operating from the Earth, which build up the crust and has been responsible for the variation in the outer surface of the crust. The Earth's surface is being continuously subjected to external force reduced basically by the energy sunlight. That is the main external force. Of course, the internal force is still active through, though with different intensities. That's that means Earth's surface is being continuously subjected to by external forces originated within the Earth atmosphere and by internal forces within the Earth. So within the Earth, the external forces is known as exogenic forces, and the internal forces are known as endogenic forces. The action of exogenic force results in wearing down, degradation of relief, elevation, and filling up. That is aggregation of basin or depression on the Earth's surface. The phenomena of wearing down of relief variation of the surface of Earth through erosion is called gradation. The phenomena, wait, too bad. Just to the point. Wearing down of relief variation of the surface of Earth through erosion is called gradation. Endogenic, that is from the inside. Endogenic forces continuously elevate or build up parts of the Earth's surface, and hence the exogenic forces fail to even out the relief variation of the surface of the Earth. So variation remains as long as the opposing action of the exogenic and the endogenic forces continues. In general term, the endogenic force are mainly land building forces, and the exogenic processes are mainly land bearing forces. One makes up the land, one bear down the land, basically. The surface of Earth is sensitive. Human depends on it for their sustenance and have been using it extensively and intensively. So it is essential to understand its nature in order to use it effectively without disturbing its balance and diminishing its potential for the future. Almost all organisms contribute to sustain the Earth's environment. However, human has caused extensive damage to the environment through overuse of resources. Use we must, but also leave its potential enough to sustain life through the future. Like we are living in now, like destroying everything in now. We are not thinking about the future at all. Like how our children and their children will live. And basically, they will fight for their resources, which we are not doing right now. Most of the surface of the Earth has been shaped over a very long period of time, hundreds and thousands of years, and because of its use and misuse by human, it is its potential is being diminished at a fast rate. If the processes which shaped and are shaping the surface of the Earth, if the processes which shaped and are shaping the surface of the earth into varieties of form and the nature of the material which it's composed of are understood, and precaution can be taken to minimize the detrimental effects of human use to preserve its posterity. That's a very long sentence. Okay. Geomorphic processes. Would you like to know the meaning of geomorphic process? The endogenic and the exogenic force causing physical stress and chemical action on the earth material and bringing about the changes in its configuration of the surface of configuration of the surface of earth is known as geomorphic process. The endogenic and exogenic causing physical stress and chemical action. Physical stress is caused by endogenic and the chemical action is caused by exogenic forces on the earth material, and the bring about a change on the configuration of the surface of the earth is known as geomorphic processes. This one more term, diastrophism. Diastrophism, yeah. Diastrophism and volcanism are endogenic force, endogenic geomorphic processes that come from the inside. And volcanism are endogenic geomorphic processes. This have already has been discussed in the brief in the preceding units. Weathering, mass wasting, erosion, and deposition are exogenic geomorphic processes. That's why they are called chemical action. Because chemical action are irreversible. That's why erosion are irreversible. Decomposition are irreversible. That means exogenic forces are irreversible because they're chemical actions. That's why these exogenic processes are dealt with in these exogenic processes are dealt with in detail in this chapter. Any exogenic element of nature like water, ice, wind, capable of acquiring and transporting earth material can be called a geomorphic agent. Any exogenic element. So what are the exogenic elements? Like water, exogenic elements are water, ice and wind. Capable of transporting earth material is called. So these are the geomorphic agents. What? Water, ice and wind. It's like this one, geomorphic agent. But water, ice, when this element of nature becomes mobile due to gradient, they move the material and transport them over the slope and deposit them at the lowest level. Lowest level due to gravitation. Geomorphic process and geomorphic agents. Geomorphic process and geomorphic agents, especially exogenic, unless stated separately, are the one and the same. Unless stated, both are the same. That's why we are calling geomorphic processes together. Okay. There's nothing to talk about. A process is a force applied on Earth material affecting the same. An agent is a mobile medium like running water, moving ice. This one agent, which is transporting water, called geomorphic agent. Okay, already. Why are you explaining two times? Good thing. Get that. Do you think it is essential to distinguish geomorphic agent and geomorphic process? Yeah, it is able to distinguish geomorphic agent or the exogenic agents like diamond. Yeah, weathering masses, wasting, erosion, recovery are geomorphic process. Exogenic process are dealt with any exogenic elements like of nature like waters are called exogenic and the exogenous volcanic and exogenic because they are weathering. Die. Okay, well, just wait. Besides gravity being directional force activating all downslope movement of the matter, which also cause stress on the earth materials, in indirect gravitational stresses activates wave and tide, induce current and wind. Without a gravitation and gradient, there would be no mobility and hence no erosion. Transportation and decomposition are possible. So gravitational stresses are the most important most as other geomorphic processes. Gravity is the force that keeps us in contact with the surface, and it is the force that switches on the movement of all the surface material on Earth. All the movement within the Earth or the surface of the Earth occurs due to gradient from higher to lower level, from high pressure to low pressure area, etc. Let's go. Endogenic processes. The energy eman- emanating emanating the energy emanating from within the earth is the main force behind the energy emanating. I don't think I will remember this emanating. That's energy from within the earth is the main force behind the endogenic geomorphic process. This energy are generally generated by these energy are mostly generated by radioactivity, rotational, tidal friction, and primordial heat from the origin of the Earth. So we can conclude that from the origin of Earth. Wait. Energy generated by inside of Earth. First one is radioactivity. Second one is rotational. Third one is tidal friction. And the last one is primordial. Primordial heat. Primordial heat from the origin. Primordial heat. region of the Earth. I will display this somewhere. So, after the original, this energy due to geothermal gradient and the heat flowing from within induces dimorphism. Dash, 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 okay, diastrophism and volcanism in the lithosphere. The induces the lithosphere due to variation in geothermal gradient and heat flow from within, crustal thickness and strength and the action of endogenic forces are not uniform as the tectonically controlled original crust is crustal surface is uneven. Why the tectonic plates are uneven? Due to action of endogenic force are not uniform. Tectonic. Tectonic plates are uneven. Okay, get that. Diastrophism. All the processes that move, elevates, or build up the portion of Earth crust comes under a diastrophism. Okay, this is a good. All the processes that move, elevate, or build up the portion of Earth crust comes under diastrophism. They include orogenic processes involving mountain building. So orogenic processes are mountain building through to severe folding and affecting long and narrow bed of the earth crust. Next is epeirogenic process involving uplift and wrapping of large part of earth crust. So once cause the folding, another just involve uplift or wrapping of large part of earth crust. Third is earthquake involving local relative minor movement, and last one is plate tectonic involved horizontal movement of crustal plates. In the process of orogeny, that is mountain building, the crust is severely deformed into folds. This. Pressure is applied from here. So it's like mountain like this. In simpler terms. Is it permanent? Okay. In the process of orogeny, the crust is severely deformed into fold. Due to epeirogeny, there may be simple deformation. Orogeny is the mountain building process, whereas the epeirogeny is continental building process. So there is a difference. Orogeny is mountain building process, whereas the epeirogeny is a continental building process. To the processes of orogeny and epeirogeny, earthquake and tectonic plates, there can be faulting, fracturing of crust. All these processes caused by pressure volume. Okay. All these processes cause pressure, volume, and temperature changes, which in turn induce metamorphism of rock. Okay. Epeirogeny and orogeny cite the differences. What is the difference? Epeirogeny is mountain building, while the epeirogeny is continental process. One forms simple deformation, and another forms like severe deformation. SEVE severe simple formation. Okay. The next is volcanism. Volcanism includes the movement of molten rock, that is magma, into toward the Earth's surface, and also for formation of many intrusive and extrusive volcanic forms. Many aspect of volcanism has already been dealt in details under volcano in unit, like in the previous chapter itself, under the igneous rock in the preceding, under the igneous rock in the preceding. So the coming unit will read more about it. So what do the word volcanism and the volcano indicates? Volcanism. This is a volcanism is a process how a volcano, like how magma comes out. This this is the mountain in this volcano state basically. Display. Exogenic process. The exogenic process derives the energy from atmosphere determined by the ultimate energy from the energy is from the sun, and also the gradient created by tectonic factors. Why do you think the slope and the gradient are created by tectonic factors? Let's read. Gravitational force act upon all the earth materials and have a sloping surface and tends to produce movement of matter in downslope direction. This force applied per unit area is called stress. Stress is produced in a solid by pushing and pulling. This induces deformation. Force acting along the face of the earth material are shear stress separating forces. It is the stress that breaks rocks and other materials. The shear stress results in angular displacement of slippage. Besides the gravitational stress on earth material becoming, this is too much sciencey. Chemical process normally lead to loosening of bond between the grains, dissolving soluble mineral and cementing materials are basic reason that lead to weathering and mass movement, erosion and development. Let's leave it. Temperature and precipitation are two important climatic elements that control various processes. So this also comes under exogenic process, like agents. Temperature is also one of the agents for exogenic process, and precipitation is also. All the exogenic geomorphic processes are covered under a general term called denudation. Let's mark it. Are covered under a general term called denudation. The word denu means stripping off or to uncover. Weathering, mass wasting movement, erosion, and transportation are included in denudation. What this is this strip talks outer material mass wasting and movement also degrades. Erosion and transportation are also included in denudation. The flowchart in 5.1 give the denudation processes and their respective driving force. As is, let's do that. So here's the denudation process. So we get it last three main areas. Like the first one is weathering. This is the processes. What causes weathering? Gravitational, molecular stresses and chemical action driving force behind weathering. So what is the driving force behind mass movements? It's gravitational force. The last one is for erosion and transportation is kinetic energy. Okay. Driving force. It should be clear from this chart. Yes, it was clear. Clear from the chart that for each process there exists a distinct driving force for energy. as there are different climatic region owing to variation in thermal guidance created by latitudinal, seasonal, and land and water spread on the surface of Earth, the exogenic geomorphic process varies from region to region. The density and types and distribution of vegetation, which largely depends on the precipitation and temperature, also exerts influence indirectly on exogenic geomorphic process. Within different climatic regions, there may be local variation of the effect of different climatic element due to altitudinal differences versus altitudinal differences in the like in the same region. Like in let's take India. India, like there is different climatic region. For Himalaya, there will be different climatic region, and from Delhi, it will be different time. So local variation, there is a local variation within them. Altitudinal different aspect variation and the variation in the amount of isolation received by north and south facing slope as compared to east and west facing slopes. Further, due to difference in wind velocity, the direction, wind direction, amount of kind of precipitation, its intensity, like there are multiple like variation, lots of variation. Even this is too much. Freezing cause, depth of frost penetration, geomorphic was a variant between like there are a lot of. So what is the sole driving force behind the exogenic force? The main, the main thing, the main thing we have to write like might come. I don't think I have to write all the things. Climatic force being equal, the intensity of action of exogenic geomorphic process depend upon types and structure of the rock. So climatic variety being equal, so main the depends upon the types and structure of the rock. Basically, it's degrading the rock. Now it depends upon the rock how it get degraded. If there is a stronger rock like full of minerals, so it will take a lot of time to degrade. Yes, but if there is like hollow rock, like which has low density, it will like weather easily or take less time to degrade. The term structure includes aspect of rock as a fold, fault, orientation, inclination, bed, as fold, fault, orientation, inclination of bed, presence of or absence of joint, bedding, planes, hardness, softness of the constituent minerals, software of constituent minerals, chemical susceptibility, susceptibility of minerals constituent, the permeability and impermeability. Permeability means if the water can penetrate it, if water can't penetrate it, that's why one is permeable and one is non-permeable. Etc. Different types of rock with differences in their structure offer varying resistance to the various geomorphic processes. A particular rock may be resistant to one process and non-resistant to another. Under various climatic conditions, particular rock may exhibit different degree of resistance to geomorphic process, and hence they operate at differential rate and give rise to different in topography. The effect of most of the exogenic processes are small and slow and may be imperceptible in short time span, but will in the long but will in the long term affect the rock severely due to continuous fatigue. So the effect of exogenic force are small and slow and may be imperceptible in short span, but it will what in the long run It will affect the rock severely due to continuous fatigue. Finally, it boils down to one fact that the differences on the surface of Earth or the surface of through originally related to the crustal evolution continues to exist in some form or the other due to difference in the types and the structure of Earth material, differences in geomorphic process and its rate of operation. Some of the exogenic geomorphic processes have been dealt in details here. First one is weathering. Okay, the first is weathering. Weathering is the action of element of weather and the climate over Earth material. This is the most simplest answer. Weathering is the action of element action of elements of weather and climate over the Earth material. There are a number of processes within weathering which act either individually or altogether to affect the Earth materials in order to reduce them to fragmental state. Weathering is defined as the mechanical. This is the more scientific answer. Weathering is defined as the mechanical disintegration and chemical decomposition of rock through the action of various elements of weather and climate. And let's make it this way. So this looks like some more important. As very little or no motion of material take place in weathering, it is an in situ or on-site process. In this little motion, which can occur sometimes due to weathering synonyms or with transportation, if not why, is this little motion which can occur sometimes due to weathering synonymous weathering synonymous with transportation, if not why. Weathering processes are conditioned by many complex geological climatic, topographic and vegetative factors. Climate is particular importance. Climate is particular importance. Not only weathering processes differ from climate to climate, but also the depth of weathering mantle. It depends upon the climate. So let's view this in 25. Let's make it 50. So here's a precipitation number. So as we go higher in altitude, the precipitation increases. Precipitation with how fast the atmospheric vapor becomes liquid. The temperature also that increases, precipitation increases, ocean, steep, semi-desert, tropical forest zones, climate regime, depth of weathering, mantle, adaptive shock. Zone of little chemical option. So these are zone of let me yeah. This one is the zone of least. Zone of moderate to good chemical alteration, because it is covered by the fourth zone. That's why there is moderate to good chemical alteration. The first one gets fourth ones get a little more chemical action than the third one. Lastly, let's leave it. Samana. Who made this? What man NCRT. What are you doing? Activity mark the light. Now, second after weathering, but also the depth of weathering mantle. There are three major group of weathering. First is the physical one. First is the chemical one, chemical weathering. Second one is physical or mechanical. This mostly happen due to gravitational force or movement of being by movement of the rock. Biological weathering versus biological, like due to like a plant has grown over a rock and gradually it will like break down the rock. Biological weathering process. Very rarely does any one of these processes ever operate completely by itself, but quite often a dominance of one process can be seen. Chemical weathering process. A group of weathering process via solution, carbonation, chemical as carbonation, hydration, oxidation, and reduction agent on the rock to decompose, dissolve, to or reduce them to a fine clastic state to chemical reaction by surface, oxygen, surface of soil, water, or other acid. Water and air mainly is composed of oxygen and carbon dioxide, along with the heat, must be present to speed up the chemical reaction. Over So water and oxygen act as a catalyst that speeds up the chemical reaction. Anything that speeds up the chemical reaction is called as catalyst. So water and air, along with heat, act as a catalyst. Over and above the carbon dioxide present in air, decomposition of plant and animal increases the quantity of carbon dioxide underground. These chemical reactions on various minerals are very much similar to the chemical reaction in laboratory. Next, physical weathering process. Physical or mechanical weathering process depends on some force, on some applied force. The applied force could be gravitational force, first one, such as overburden, pressure, load, shearing, stress. Now, and the second one is expansion force due to temperature change, crystal growth, animal activity. And the last one is water pressure. Water pressures controlled by wetting and drying cycle. Many of these forces are applied at the both surface and within different earth materials, leading to rock fracture. Most of the physical wearing processes are caused by thermal expansion, like heating, thermal expansion and pressure release. This process most these processes are small, slow, but can cause a great damage to the rock because of the continuous fatigue, similar as the oceanic. Yeah, this one. The effect of the oceanic are small, slow, maybe imperceptible in short manner, but in long term it will cause severe continuous fatigue. Similarity it has also the same answer. Due to continuous fatigue to repetition of contraction and expansion. This is biological activities and weathering. Biological weathering is contributing to removal of mineral and iron from the weathering. Biological weathering is contribution to or removal of mineral or iron from the weathering environment or physical changes due to growth or movement of organism like plant, fungus, and yeah, same things. And burrowing, wedging by organism like earthworm, termite, rodent help in exposing new surface to the chemical attack and assist in penetration of moisture and air. Human being, human being by human beings by disturbing vegetation, plucking and cultivating soil also help in mixing and creating new contact between the air, water, and minerals in the earth materials. Decaying plant and animal matter help in production of humic. Decaying plant and animal matter help in production of humic, carbonic, and other acid, which enhances decay and solubility of some elements. Solubility of some elements. Okay, some elements. Solubility of some minerals will be a more appropriate answer. Okay, nevertheless, plant roots exert tremendous pressure on Earth's material mechanically, breaking them apart. So, what are plant roots exert tremendous pressure on Earth material to break them apart. Special effect of weathering: exfoliation. Exfoliation, like you know, exfoliate your skin through face wash. That's one thing. You can use all the sand as an exfoliating agent for your skin. Okay, the next one, exfoliation. This has already been explained under the physical weathering process of unloading. Okay, in thermal contraction, expansion, and salt weathering. Exfoliation is a result, but not a process. Is a result. Exfoliation is a result. It's not a process. But exfoliating skin is flaking off of more or less curved sheet or shell from rock or bedrock result in smooth and rounded surface. This one, exfoliating, flaking, granular, no, not granular, this is granular disintegration. Granular disintegration. Exfoliation can occur due to expansion and contraction. Exfoliation can occur due to expansion and contraction induced by temperature changes. Exfoliation domes and to results due to unloading and thermal expansion respectively. So this is the curve, beautiful curve made by exfoliation. Significance of weathering. Weathering processes are responsible for breaking down rocks into smaller fragments. The weathering processes are responsible for preparing their way for formation of not only regolithic, regolith, regolith, not only regolith, this is a new command. Regolith. Let's make it a green one so that I can go through it when I read it again. And find a meaning, but and soil, but also erosion and mass movement. Biomes. Biomes and biodiversity is basically a result of forest and the forest depends upon the depth of weathering mantles. Erosion cannot be significant if the rock is not weathered. Well, cannot be significant if rock is not weathered. Basically, is if rock is not broken down, so water is effect. That means weathering aids mass wasting and erosion and reduction in relief and changes the landform are the consequences of erosion. Weathering of rock and deposit help in enrichment. Okay, now here is the more better part. How weathering is useful for us. Let's slide it. Weathering is weathering of rock and deposit help in enrichment and concentration of certain valuable ores, manganese, aluminium, which are of great importance for national economy. Okay. Weathering is an important process in the formation of soil. Okay, this is also this we have learned since class 6 or 7. Not 6, basically from 8 and 8. So when rock undergo weathering, some materials are removed through chemical or physical bleaching by underground water, and thereby concentration of the remaining materials increases. Okay, so the shallow compound, which are like soluble compounds, get like washed away due to groundwater, and what remains is a much denser material, which is valuable, more valuable. Without such weathering taking place, the concentration of the same valuable material may not be sufficient and economical valuable to exploit, process and refine. This is called enrichment. Wow. This whole thing is okay. I'm overkilling. It was overkill. Without such phasing techniques, the concentration of same valuable material may not be sufficient and economical valuable to exploit, process and refine. Okay, it's done. Now next is the mass movement. Mass movements. Mass movements. These movements transfer the mass of rock debris. I'm so sorry, sir. These movements transfer the mass of rock debris down the slopes under the direct influence of gravity. That means air, water, or ice do not carry debris with them place to place. But on the other hand, the debris may carry with it air, water, or ice. So that means let's read it once again. Even I'm not getting it. These movements transfer the mass of rocks debris down the slope under direct influence of gravity. Okay, that means air, water, ice do not carry debris with them from place to place. But on the other hand, the debris may be carry with it air, water, or ice. So the debris, like if an ice block is swimming across a large swimming like it's reached a large area, so it's going through the force of gravity, right? Influenced by the force of gravity. And what is it that debris is carrying with it? The block of ice. It's carrying its mineral, its water, and all. And that's what is basically a small example I'm trying to give. What it is trying to say. Okay, next. The movement of mass may range from flow to rapid, affecting shallow to deep column of materials, and can include creep, flow, slide, and fall. What does it include? Creeps, flow, slide, and fall material. Gravity exerts its force on all matters, both bedrock and the product of weathering. So weathering is not a prerequisite for mass movement. Though it aids mass movement are very active over weathered slope rather than under weathered materials. So humans are very active over weather slopes. So so basically जहाँ ढलान ज़्यादा होगा वहाँ पर ज़्यादा मास मूवमेंट होगा rather than over under weather materials. Mass movement are aided by gravity and no geomorphic agent like running water. Aided by gravity and no running water, glacier, wind, water, current, precipitation in the process of mass movement. That means mass movement do not comes under the erosion. Though there is a shift aided by gravity, of course, of materials from one place to another. Materials over the slope have their own resistance to the disturbing force and will yield only when the force is greater than the shearing resistance of the materials. Weak and unconsolidated materials, thinly bedded rock, falls, steeply dipped beds, vertical cliff or steep slope, abundant precipitation and torrential rain, and scarcity of vegetation favor mass movement. Severe activities cause preceding mass movement. They are several activity causes precede several activity causes precede mass movement. They are removal of support from below materials, like taking its support from the below by natural or artificial means. Second is increasing gradient and height of slope, overloading through addition of materials naturally or by artificial filling. over overloading of heavy rainfall, which also causes mass movement. Saturation and lubrication of slope materials. Removal of materials or load from over the original slope surface. Occurrence of earthquake, explosion, machinery, excessive natural seepage, the heavy drawdown of water from lakes, reservoir, or river, leading to slowed outflow of water from under the slope or riverbank. Next is indiscriminate removal of natural vegetation. HAVE. Okay, this is the name what I have learned. HAEV, HAVE. That means heaving up of soil due to frost growth. Another cause. Flow and slide are three forms of movement. Heave, flow, and slide are three forms of movements. Flow and slide are three forms of movements. And the relation among the different types of mass movement, their relative rate of movement and moisture limits. Now, next one is a landslide. This also considered movement, right? These are relative rapid and perceptible movement. The materials involved are relatively dry. The size and the shape of the detached mass depends upon the nature of discontinuities in the rock, the degree of weathering, and the steepness of the slope. So, what is the shape of the detached mass? The nature of discontinuity in the rock, degree of the answer. Okay. And the steepness of the slope. Depending upon the types of movement of the material, several types of identified in this category. Now, depending upon the movement of material, several types of movement of. So these are the types. Let's write the types. The first one is slump. The second one is there's no second one. The slipping of on a several unit of debris with backward rotation. Slumping of debris with backward rotation. So what is happening here? Initial position of the slope. Okay, this is the initial slope. Now slumping shows a backward rotation. So it's going down, but due to sense of gravity, it's like rolls and goes back up. Slump showing a backward rotation of the materials. No, that it doesn't go like that. When the gravitational heads, like this is a clean cut. Okay, so it's going down. So material which are here supposedly it's too much. Leave it. Even I am not understanding what it's trying to say. Slumping of debris and backward rotation. Slumping is slipping off one or several units of rock debris with backward rotation with respect to the slope. With respect to the slope, initial position of the slope. It falls down. So next is rapid rolling and sliding of debris without backward rotation. Second one is rapid rolling or sliding of debris without rotation, a debris slide. Next one is debris slide. DEPRI debris slide. And a sliding of individual rock bearing upon a this is rock slide. So this all comes under a landslide. Bearing on okay, landslides. The slide occurs as planar failure. The ground continuity is like bedding plane static. Rock fall from free falling rock block away from slope. Rock fall occurs from the superficial layer of rock face. An occurrence of distinguished from rock slide materials. Oh, this is left. Let's see. This is a big chapter. Between mass wasting and mass movement, which term do you feel is most appropriate, and can fluxion, and can solifluction be included under rapid flow movement, and why it can and why it can't? Superficial. I haven't read about solifluction because it's not given, so I don't know what solifluction is. I can guess like turning off solid into liquid, maybe. In our country, debris avalanches and the landslide occurs very frequently in Himalayas. There are many reasons for this. First one is this is the important one. The first one, Himalayas are tectonically active, still active, and they are mostly made up of sedimentary rocks, and sedimentary rocks are very fragile. They are made up of sedimentary rocks and unconsolidated and semi-consolidated deposits. The slopes are very steep. Next one is the slopes are very steep compared to Himalayas. The Nilgiris bordered Tamil Nadu, Karnataka, and Kerala, and Western Ghat goes along western coast are relatively tectonically stable and are mostly made up of hard rocks, like Deccan Traps and all. It is made up of lava. Western Ghats, Western coast. These are basically made from Himalayas are basically made from fold mountains, like folding of mountains. But still, debris avalanches and the landslide occurs, though not very frequently, as in the Himalayas in these hills. Why? Even I am not getting the question. Still, debris avalanches and landslide occurs, though not as frequently as in the Himalayas in these hills. Why? Many of the slopes are steeper, almost vertical cliff, and escarpment of the Western Ghat and Nilgiris mechanically weathering due to temperature change and ranges is pronounced. They receive very heavy heavy amount of rainfall over short period. So there is almost direct rock fall frequently in these places, along with landslide and debris avalanches. Mechanical weathering due to temperature change and ranges is pronounced. They receive heavy amount of rainfall over short period. Tree avalanches and rock slide occurs, though not as frequently as in the Himalayas in its areas. Why? Many slopes are steeper, versus the slope are steeper with almost vertical cliff encarpment in Western Ghat and Himalayas. Mechanical weathering is due to temperature change, ranges is pronounced. So these all the things. That's why Himalaya suffers a lot of avalanches. Okay. So next one is erosion and deposition. So erosion involves acquisition and transportation of rock debris. But erosion involves acquisition and transportation of rock debris. So this is the common one. Okay. Erosion involves acquisition and transportation of rock debris. When massive rock break into smaller fragments through weathering and any other process, erosional geomorphic agent like running water, groundwater, glacier, wind, and wave removes and transport it to another place depending upon the dynamic of each of these agents. Okay. So erosion depends upon the weathering agent. Erosion depends on the weathering agents. Oh no, erosional geomorphic agents like running water, ground, glaciers, and wave removes and transport to another depending on the dynamic. This is so much. Here is the wind and wave. Now is abrasion. Abrasion by rock debris carried by geomorphic agent also aid greatly in erosion. By erosion, relief degrades, and that is the landscape is worn down. That means through weathering aids erosion. Though weathering aids erosion, it is not. That means though weathering aids erosion, it is not a precondition. What? Weathering is not a precondition for erosion. Like it's not prerequisite for erosion to happen. For erosion to take place, weathering is a weathering is basically mass wasting, and erosional is degradational process. Okay. One more thing, erosion like soil erosion. Erosion like it takes out the like good property of the soil. So erosion is particularly a bad thing. So whereas weathering, though it's wear down the soil, but it not necessarily like takes down its fertility part. Like it's actually weathering helps in like making soil more better than erosion. Weathering like, it is a direct loss of erosion is direct loss of like fertility of soil. If I take soil as an example, weathering mass wasting and erosion is mass wasting. Just let's make this a green one. Weathering mass wasting and erosion are degradational process. Like it degrades. It is erosion that is largely responsible for continuous changes that the Earth's surface is undergoing. As indicated in 6.1, this 6.1 is way down. Maybe next chapter, because this is chapter number 5 and we are well ready to next chapter. As indicated in 6.1, denudational processes like denudational processes like erosion and transportation are controlled by kinetic energy. The erosion and transportation of earth material is brought by wind, running water, glaciers, waves, and groundwater. Of these first three agents are controlled by climatic condition. This, and this climatic condition. They represent the three states of matter: gaseous, wind, and solid gas glacier. Now you can compare this 3 climatically controlled agents. The work of other two agents is the work of other two agents of erosion waves and groundwater is not controlled by climate. That is this one and this one. It's not controlled by climate. In case the wave, it is the location along the interface of lithos and hydrosphere, coastal regions that will determine the work of waves, whereas the work of the groundwater is uh, determined more by the lithological character of the region. If the rock are permeable and soluble and the water is available, then karst topology develops. Karst topology develops. In the next chapter, we shall see the landform produced by each of these agents of erosion. Next, deposition is a consequence of erosion. So deposition is a consequence of erosion. Erosional agent loses their velocity and hence the energy on gentler slopes, and the material carried by them started to settle themselves. In other words, deposition is not actually the work of any agent. The coarser the material, it get deposited first, and the finer ones later. By decomposition, depression gets filled up. Depression that is this one. This is called let's assume to the surface. This is the depression. And depression on the surface of Earth. Okay. Now the materials which are uneven size material, they get deposited first, and the fine particles like these fine particles or these particles, they get deposited on the top. That's why we have bedrocks. So the next one is deposition is a consequence of when the erosional agent lose their velocity. We have read this. Decomposition not actually the work of any agent. The coarser the material, it gets deposited first. The coarser the material get deposited. Coarser the material, it gets deposited, and final one later. By deposition, deposition gets filled up. The same erosional agent like running water, glacier, wind, waves, and groundwater act as an aggradational or decompositional agent. So by decomposition, depression, the same erosional agent, that is running water, glacier, wind, wave, groundwater act as an aggradational or decompositional agent also. What happens to the surface of Earth due to erosion and decomposition is elaborated in the next chapter in the landform and their evolution. There is a shift in material in mass. So there is a shift of material in mass movement as well as in erosion from one place to another. So why can't both be treated as one and the same? There is a material in mass and erosion in one place to another. So yes, this is a genuine question. Can there be a appreciable erosion without rock undergoing weathering? So let's see. We'll get this answer. The soil formation. You see plant growing on soils. You play in the ground and come in contact with soil. You touch and feel soil, and soil your clothes while playing. Can you describe it? The soil is a dynamic medium in which many chemical and physical and biological activities goes on constantly. Soil is a result of decay of basically rock, but it is a result of decay. It is a medium. It is a medium for growth. But soil is a medium for growth. It is changing and developing bodies. It has many characteristics that fluctuate with the season. It may be It can be alternatively cold and warm and dry and moist. Biological activity is slowed and stopped if the soil becomes too cold or too dry. Organic matter increases when leaves fall and grasses die on soil. The process of soil formation. Soil formation. This is given in the first chapter itself. Videogenesis is a process called soil formation. The process of soil formation is called videogenesis. Then let me write here. So in the pedogenesis, like, wow, GENESI means process of formation of formation of it is weathering depends on weathering. It is this weathering mantle depth from which whatever it is mantle which is basic input for the soil to form. But it's mantle that's come from inside of the earth. First, weathered materials or transported deposit are colonized by bacteria. Okay, and other first weathered material or transported deposit are colonized by bacteria. The first instances get by bacteria and other inferior, like small inferior bodies like moss and lichens and other inferior plant bodies like mosses and lichens. Also, there are very with several minor organisms may take shelter within the mantle and deposits. The dead remains of organism and the plant help in humus accumulation. Humus, that is a humus accumulation. It is good for the growth of all the small organisms. Minor minor grasses and ferns may grow. Later bushes and tree will start growing through seed brought up by the birds and the wind. Plants to penetrate down, burrowing animal, bringing up particles. Mass of materials become porous and sponge-like with a capacity to retain water and to permit tiny passes of air. And finally, a matured soil, a complex mixture of minerals, organic product is formed. Is weathering solely responsible for the soil formation? If not, why? Okay, this is a good one. So here, pedogenesis is the process of formation of soil, and here pedology is the soil science. That is, it is a soil scientist is called pedologist. This is such a I think he likes kids a lot. This pedologist. Soil forming factors. Five basic factor control the formation of soil. First is the parent materials. That is the material of which, like the rock, basically the rock. Next, the topology of that areas. Climate, biological activities like organism eating away the rock, penetrating the rock, basically, and the time. More the time, more refined rock. In in fact, forming factors acts in union and affect the action of one another. Like these, all the factors contribute, not just one. All the factors contribute simultaneously for the formation of soil. Parent material. Parent material is a massive control factor in soil formation. Parent material can be in situ and on situ weathered rock debris. Residual soil. Transported deposits. Soil formation depends upon the extreme texture, size of the debris, and the structure as well as the mineral. Soil formation depends upon the texture, size and structure, as well as the mineral and chemical composition of the rock debris or deposit. Nature and the rate of weathering and the depth of weathering mantle are important consideration under parent materials. There may be differences in soil over similar bedrock, and the dissimilar bedrock may have similar soil above them. But when soil are very young and not have matured this when soil are very young and have not matured this show strong link with the types of parent. Also, in case of some limestone areas where the weathering process are specific and peculiar, peculiar, and soil will show clear relation with the parent rock. Topography is like parent material in another passive control factors. Influence of topography is felt through the amount of exposure of a surface covered by a parent rock to a significant sunlight or amount of surface and subsurface drainage over and through the parent materials. Soil will be thin on the Soil will be thin on steep slopes and thick over the flat upland areas. Over gentle slopes where the erosion is slow and percolation of water is good, soil formation is favorable. So we get a question: where is the soil formation is favorable? Favorable. It is favorable over gentle slope, where erosion is slow and percolation of water is good. Soil formation is very favorable. Soil over flat areas may develop a thick layer of clay with good accumulation of organic matter, giving soil its dark color. The next factor is climate. Climate is an important active factor in soil formation. Climatic element involved in soil development are: first one is moisture in terms of intensity, frequency, and diffusion of precipitation and evaporation and humidity. The second one is temperature in terms of seasonal and diurnal variation. Diurnal variations. Precipitation gives soil its moisture content, make the chemical and biological activities possible. Excess of water helps in downward transportation of soil components through soil. This is a good one. Illuviation, that means when excess water helps in downward transportation of soil component through soil, it's called illuviation. Okay, deposits, deposit deposit like the stream down below. That's illuviation. Deposit. Okay, in climates like wet equatorial rainy areas with high rainfall, not only calcium, sodium, and magnesium, potassium, but also major part of silica is removed from the soil. Removal of silica from soil is called desilication. Desilication. In dry climate, because of high temperature, evaporation exceeds precipitation, and hence groundwater is brought up to the surface by capillary action. And in the process, the water evaporates, leaving behind salt in the soil. Such salt forms into a crust in the soil known as hard pan. Forms on the crust of due to evaporation. Salt forms on the crust of into a crust in the soil is known as hard pan. In tropical climates and areas with intermediate precipitation condition, calcium carbonate nodules like canker are formed. Temperatures act in two ways: increasing or reducing chemical and biological activities. So when the temperature like decreases, there is a reduction in chemical and biological activities, and if the temperature increases, there is an increase in chemical and biological activities. Maybe. Okay, let's see. The chemical activity is increased in higher temperature. Okay, the same as chemical. Yeah, this is. So chemical activity is increased in higher temperatures and reduced in cooler temperatures, except with carbonation, and stops in freezing conditions. That's why tropical soils with higher temperatures show deeper profile, and in the frozen tundra region, soil contains large mechanical broken materials. Now the next condition is for soil formation. Factor for soil formation is biological activity. The vegetative The vegetative covers an organism that occupy the parent materials from the beginning and also at later stage help in adding organic matters, moisture retention, nitrogen, etc. Dead plants provide humus, the finely divided organic matter of the soil, some organic acid which forms during humidification aids in decomposing the minerals of the soil parent materials. Intensity of bacterial activity show up the differences between soil of cold and warm climate. Humus accumulates in cold climate as bacterial growth is slow. With under decomposed organic matter because of low bacterial activity, layers of a peat develop in sub-Arctic and tundra climate. In humid tropical, in humid In humid tropical and equatorial climate, bacterial growth and action are intense and dead vegetation is rapidly oxidizing. Dead vegetation is rapidly oxidizing, leaving a very low humus content in the soil. Further, bacteria and other soil organisms takes take gaseous nitrogen from air and convert it into chemical form that can be used by plants. This process is called nitrogen fixation. So the bacteria and the other soil organisms that take gaseous nitrogen from the air and convert it into plant form as used by plant. This was called gram. Gram is an example of it. Chana. Rhizobium. Rhizobium is the type of bacteria that lives in the root modules of leguminous plants and fixes nitrogen beneficial for the host plant. The influence of large animals like ant, termite, earthworm, rodent, etc. is mechanical, but it is nevertheless important in soil formation as they rework the soil up and down. And in case of earthworms, as they feed on soil, the texture and the chemical of the soil comes out of their body changes. Time is the third important factor in controlling. Time is the third important controlling factor in soil formation. The length of time the soil formation process operates determines the maturation of the soil and profile development. A soil becomes mature when all the soil forming processes act for a sufficiently long time, developing a profile. Soil developing from recently deposited aluminum or glacial tills are considered young, and they exhibit no horizon or only poorly developed horizon. No specific length of time in absolute term can be fixed for a soil to develop and mature. So no length of time in absolute term can be fixed for soil. Necessary. Okay. Last one. What's the decomposition? Which of the following process is a gradual process? Gradation process is stakes. Decomposition is a erosion is a yes, answer gradation. Yes, breaking down of precipitation through erosion is known as gradation. Which one of the following material is affected by hydration? Which of the following material is affected by hydration? I think salt is mostly affected. Debris avalanches can be included in which category? It's rapid flow, mass movement, slow landslide. Rapid flow mass avalanches, rapid flow mass movement, landslides, debris avalanches. See avalanches, landslide, debris avalanches. Geomorphic and debris rock debris it is. Will get answered. Still a degree and nicer occurs in Earth and so by many slow by steeper will almost many particles are referred mechanical weathering due to let's go with landslide because that is the more appropriate answer. So answer is weathering that is responsible for biodiversity on Earth and how. Yes. What are the mass movement that are real, rapid and perceptible? Various mobile and exoteric processes are running water in all the states of water, running water, glaciers and waves, and underground water. Or various mobile. What is the primary objective of mind? Is weathering essential as a prerequisite in the formation of no. So with that, chapter is done.